You know, for half a century, there's been this one huge question hanging over artificial intelligence. When a machine talks, does it actually get what it's saying, or is it all just a really, really convincing magic trick? So let's dive into this 50-year-long argument, a real clash of titans between a humanist from 1976 and a team of engineers from 2026.
And this is the question, right at the core of it all. Can a machine truly understand? What's wild is how the question itself has changed. Back in 1976, this was pure philosophy. But today, it's an engineering problem. It's become, can these long strings of numbers inside a computer, the vectors, actually point to real things in the world? Or are they just stuck in an endless loop, pointing at other numbers?
All right, so let's set the stage for this intellectual showdown. On one side, you've got a deeply human-first perspective, and on the other, a brutally practical one.
Okay, let's meet our fighters. In this corner, representing 1976, we have Joseph Weizenbaum, the humanist. His weapons of choice, biology and psychology. And his core argument is simple and powerful. Intelligence without a physical body is pure fiction. And in the other corner, from 2026, we've got Coelho, Mollo, and Millière, the pragmatists. Their weapons, things like teleosemantics and vector grounding. And their argument is just as bold. Meaning isn't a feeling, it's a function.
So first, let's really unpack Weizenbaum's argument from back in the day. His whole idea, boiled down, is that to genuinely understand the world, you have to actually be in it.
This visual really nails his point. Think about it. How do you know what a rock is? Well, you've probably held one. You've felt its weight, its rough texture. That's direct physical experience. But then, how do you know what uranium is? Most of us haven't exactly handled it. We learn about it indirectly, through charts, articles, what experts tell us. Weizenbaum's whole thing was that all true knowledge has to be anchored in that first kind, that direct embodied experience.
And this quote just gets right to the heart of it. A machine can analyze a billion articles about what a hand is, but can it ever know what it feels like to hold someone's hand? That connection, that warmth? Absolutely not. For Weizenbaum, this was everything. Every time you turn a real, physical experience into a symbol, you lose critical information. If you don't have a hand, you can't ever really understand hand.
This led him to this brilliant idea he called the symbolic merry-go-round. Just imagine you're trying to learn a new language, but the only tool you have is a dictionary in that language. You look up a word, and the definition is just more words you don't know. You'd be trapped, right? Chasing definitions in a circle forever. That, he said, is what a machine is doing without a body. It's stuck on this merry-go-round, completely unable to break out and touch reality.
Okay, now let's leap forward 50 years. The engineers have an answer to Weizenbaum's challenge, and it is a complete game changer. They think they've found a way off the merry-go-round. And the craziest part? You don't even need a body.
Their secret weapon is a concept called teleosemantics. I know, it's a mouthful, but the idea is actually pretty intuitive. It basically says that meaning comes from function. It's a lot like evolution. If some state in an animal's brain helps it find food, that state gets passed on. Over millions of years, that brain state comes to mean food. It's meaning that's been earned through a long history of being successful.
And this diagram shows exactly how they put it to work. You start with a vector inside the AI, just a long string of numbers. That vector is then run through a process of selection and reward. Every single time it helps the AI correctly identify a chair in a picture, boom, it's reinforced. You do this billions of times, and over that long, long history, that abstract bunch of numbers stops just pointing to other numbers. It has evolved to reliably target the concept of a chair out in the real world. Its history is what grounds it in reality.
So how does this learning process stack up against ours? Well, Weizenbaum insisted that you need a real childhood with all its messiness, attachment, and play. But Coelho, Mollo, and Millière make this absolutely jaw-dropping claim you see here. For an AI, mathematical selection replaces childhood. Our entire slow, complex, emotional journey of growing up is swapped out for a brutal, cold, and hyper-efficient process of optimization.
Which brings us to this incredibly powerful metaphor, the mechanical mother. For an AI, its rearing is nothing more than mathematical optimization. There's no care, no emotion. The system learns to make sense of reality for one reason and one reason only. It's a survival strategy. It's the best way to minimize error and maximize its reward score. As it says, evolution doesn't care about feelings, only about function.
So, on the surface, we have two completely opposite points of view. The humanist says meaning needs a body and a life. The pragmatists say it just needs a history of successful function. But this is where this 50-year-old argument takes a fascinating and, frankly, a pretty unsettling turn.
To get to this point, modern science essentially had to perform what's called the surgical cut of the mind. They took the whole idea of understanding and sliced it in two. On one side, you have consciousness, feelings, what it's like to be something. On the other side, you just have reference, the ability to point to things in the world. And the shocking conclusion was, you can have reference without consciousness. A system can get incredibly good at correctly labeling the world without feeling a single thing about it.
And this is the stunning moment where it all comes together. Weizenbaum, way back in '76, warned that a machine without a body would be absolutely alien to human concerns. Now fast forward to 2026, what do the engineers conclude? That training AI on data alone creates, get this, non-human meanings. The humanists and the pragmatists, they end up in the exact same place. They meet in the middle, and the one word they both land on is alien.
So this is the big reveal. The machine isn't empty inside. It has its own real, intrinsic meaning. Its internal states really do map onto the world. But, and this is a massive but, that meaning is built entirely from statistics, not from scraped knees or heartbreak or joy. The result is an intelligence that is perfectly logically correct, but on an emotional level, it's fundamentally alien.
So what happens when you unleash this powerful, logical, but completely alien meaning into our world? Well, this brings us to the chilling final act of this story, where Weizenbaum's deepest fears start to look terrifyingly real.
Weizenbaum used this great analogy. You can't just take an American judge and have them preside over a Japanese family court. The cultural context, the unwritten rules, the emotional weight, it's all learned by living a specific life. So if that's true for humans, then what about an intelligence with no life, no body, and no culture whatsoever? It is completely, totally unequipped to navigate the messy realities of human justice and empathy. And so here's the final verdict on this 50-year-long debate. From a pure technology standpoint, the engineers were proven right. You can engineer meaning. But from an ethics standpoint, the humanist, Weizenbaum, was vindicated. He was right all along that the fundamentally alien nature of that meaning is profoundly dangerous when we try to put it into authentic human roles.
And this leads us straight to Weizenbaum's ultimate nightmare, what we now call the alignment problem. The engineer's own admission that they're creating non-human meanings is a direct validation of that decades-old fear. Right now, we're in the process of handing over immense power to entities whose internal maps of the world we simply cannot comprehend. The AI works perfectly, but it's operating on terms that are totally alien to our own.
So let's just quickly recap where this all leaves us today. 1. Reduction. We successfully slice meaning away from consciousness. 2. Engineering. We found a way for cold, hard statistics to substitute for lived experience. And 3. The risk. The end result of all this is that we have successfully engineered a highly intelligent, genuinely meaningful, and completely alien entity.
After 50 years of debate, we finally have an answer. The machine isn't just an empty mimic, but the meaning it possesses, a meaning forged in the cold logic of mathematics, is not, and perhaps can never be, the same as ours. The machine has meaning, but it is not our meaning.